Let us see as to how to solve a linear programming problem of maximization using graphical method. So here is a problem in which we are asked to maximize the objective function z equal to 45x plus 80y subject to two constraints: 5x plus 20y less than equal to 400, 10x plus 15y less than equal to 450. And the non-negativity constraints as usual are x greater than equal to 0, y greater than equal to 0. So we proceed with step 1 where we consider the constraints as equations. So here we have two constraints, so there will be two equations. So let us look at the first equation. It is 5x plus 20y equal to 400, and the second equation is 10x plus 15y equal to 450. So in step 2 we take equation 1 and here we substitute x as 0. So when we substitute x as 0, we get 20y equal to 400, and y is equal to 400 by 20 gives us the value as 20. So take this as point A. So x is 0 and y is 20. So 0, 20 is our point A. Now let us take the same equation 5x plus 20y equal to 400 and assume y is equal to 0. So when we substitute y as 0, we get 5x equal to 400 and x is equal to 400 by 5 gives the result as 80. So this is our point B. 80 is x, 0 is y. So 80 comma 0 is point B. Step 3 we repeat as we did for equation 1. In equation 2 you get 10x plus 15y equal to 450. Substitute x is equal to 0 and the result is y equal to 450 by 15 gives you 30. So this is point C where 0 x value and 30 is the y value. So point C is 0 comma 30. Take the same equation 10x plus 15y equal to 450, substitute y equal to 0 and we get x equal to 450 by 10 is 45. So this is named as point D where x is 45 and y value is 0. So 45 comma 0 is point D. So now we have 4 points A, B, C, D which has to be plotted in the graph, and using this we will find the feasible solutions. So this is how the graph is plotted, and the scale is 1 unit equal to 5 centimeter and 1 unit is equal to 5 centimeter both in x axis and y axis. So after plotting A 0, 20, B 80, 0, we join both the points A and B. Same way plot C 0, 30, D 45, 0 and join the points. So on joining we get two lines intersecting at a point E. So if our graph is very much accurate in plotting, we can find the points. So here the point is 24, 14. E point is 24, 14. So how to find the feasible solution? So the rule says the points below these, the region below these points, that is A, E and D, gives us maximum value for Z. So the maximum value of Z is evolved below these points. So the region is bounded region for feasible points. So note it is A, E and D which are the best points or best optimal points in which Z gets the maximum value. The next step is just to check whether the point that we have found in the graph is right or wrong. So I am talking about point E. So we have to check out if point A is as denoted 24, 14. So how to check? Very simple. We just solve the two equations 5x plus 20y equal to 400 and 10x plus 15y is equal to 450. So this is the usual elimination method that is followed. So equation 1 is multiplied with 2. So 5 into 2 is 10x, 20 into 2 is 40y, 400 into 2 is 800. So we get a new equation 3. and subtract equation 3 from equation 2 from equation 3, and on subtracting we get 25y is equal to 355, and the y value generated is 14.2. We can approximate the value as 14. Substitute y is equal to 14 in any one equation, so I substitute in equation 1, and the answer that we get for x is 24. So the point E is 24, 14. So this is just to check whether the point that we have plotted is correct. Step 6 is the major last step in which we find the optimal point which gives maximum z value. So here we have to take the objective function, the first equation that is given in the problem, z equal to 45x plus 80y, and the points that we have found, that is A, E and D. At each point we have to find the z value. So how to find the z value? It's very simple. We just substitute the x and y values and find the answer in the equation. So first point is A, 0, 20. So x is 0 and y is 20. So 45 into 0 plus 18 into 20 gives 1600. Point E is 24, 14. 45 into 24 plus 18 into 14 gives us 2200. Third point is D, 45, 0. 45 into 45 plus 18 into 0 gives us 2025. So look at all the z values and check out which is the maximum z value. So in this case the maximum z value is at point E, 2200. So this is the result of the LPP problem. So we give the result as z value is maximum at point E, 24, 14, and the optimal solution is point E, and the optimal z value is ZE is equal to 2200. So with this problem is completed. Let us take the second problem the same way as we did the earlier one. Here the objective function is maximize z equal to 300x plus 200y, and the constraints 5x plus 2y less than equal to 180, x plus y less than equal to 45. And the non-negative constraints are x greater than equal to 0, y greater than equal to 0. So we start with step 1. Take the constraints as equations. So 5x plus 2y equal to 180, equation 1. X plus y is equal to 45, equation 2. Step 2. Take equation 1, substitute x equal to 0 and find the y value. Y is 90, 90. So point A is 0, 90. Take the same equation 1, substitute y as 0. We get 5x equal to 180. So 180 by 5 gives you 36. So this is your point B, 36, 0. Step 3. Take equation 2, x plus y equal to 45. X is equal to 0 and the y value we get is 45. So the point C is 0, 45. Take the same equation 2. Let y equal to 0. Then we get x value as 45, and this point is point D, 45, 0. So let us plot all the 4 points A, B, C, D in the graph and find the feasible solutions. So here the graph is plotted with the unit. 1 unit is equal to 10 centimeter, both in x-axis and y-axis. So on plotting A and B, we join A and B 0, 90 and 36, 0, and join C and D. C is 0, 45, D is 45, 0. We get an intersecting point E, and if our graph is very much exact, we can find the value 30, 15. So as in the earlier problem, the bounded feasible region here is under CEB. CEB. So we can use these 3 points to find the maximum Z value. Step 5 is just to check out whether we have found the point E properly or not. So we solve both the equations, 5x plus 2y equal to 180, x plus y equal to 45. Simple elimination method. So here we multiply equation 2 by 5. So we get 5x plus 5y equal to 45 into 5 is 225. Name it as equation 3. Subtract equation 3 and equation 1. And we get the answer 3y equal to 45 where y value is 15. When we substitute y is equal to 15 in any one equation, so I take equation 2, x plus 15 is equal to 45, so x value is 30. So therefore the point E as we have plotted in the graph is correct. It is 30, 15. The last step, the last major step to find the optimal point which gives maximum z value. Take the objective function z equal 300x plus 200y. Check out with each points C, E and B. So when we look at C, 0, 45, 300 into 0 plus 200 to 45 gives 9000. At point E, 30, 15, 300 into 30 plus 200 into 15 gives 12,000. At point B, 36, 0, 300 into 36 plus 200 into 0 gives 10,800. So if you look at all the values, the maximum value is at point E, which is 12,000. So the result is Z value is maximum at point E, 30, 15. The optimal solution is point E and the optimal Z value is Z is equal to 12,000. So hope you are clear with the graphical method of solving the linear programming problem, a maximization problem. Thank you.